Welcome students, myself Kale, Rayat Shikshan Samsthas, RBNB College, Rampur, Mathematics Department. 11 Science, Mathematics Part 2, Lecture number 11, Chapter number 7, Limits, Exercise 7.6. In the previous video lecture, we have completed exercise 7.1 to 7.5. Now we start here exercise 7.6, which depends upon limits of exponential and logarithmic function. Now we see here the formulas of limits of exponential and logarithmic function. First one is here, limit as x tends to the 0. Limit x tends to the 0, a to the power x minus 1 upon x. This is the first formula. Second one is here, limit as x tends to the 0, 1 plus x to the power 1 upon x. And third one is here, limit x tends to the 0, log of 1 plus x upon x. These are three formulas. So limit x tends to the 0, a to the power x minus 1 upon x. See here, a to the power x. Here power is x and divided by x, and that x tends to the 0. Then the value is here log of this number, log of a. Log of a is greater than 0, a not equal to 0 here. A should be positive and it not equal to 0. This is the first formula. Here exponential function means a to the power b. A number of the type a to the power b is called exponential function. And logarithmic function means log of x. Log of x is nothing but the logarithmic function. So now second formula, limit x tends to the 0, 1 plus x to the power 1 upon x. Here it is e. We take here limit as x tends to the 0, 1 plus x to the power 1 upon x. Here x means x upon 1, and here it is the reciprocal of this x upon 1, here 1 upon x, and this x should tends to 0, then the value is e. Okay, here e is 2.7 and like this, e is equal to 2.7 etc. 1 etc. So now here third formula obtain, we obtain this third formula from the second. In second formula, suppose here limit as x tends to the 0, log of 1 plus x to the power 1 upon x. Okay, here we take only log. Now here take log outside the limit, and we write this as log of limit as x tends to the 0, 1 plus x to the power 1 upon x. We take log outside the limit. And now from second formula, limit x tends to the 0, 1 plus x to the power 1 upon x, it is e. So it is equal to log of e, and log of e is 1. So log of e, it is equal to 1. Okay, and therefore we get here limit as x tends to the 0, limit x tends to the 0, log of 1 plus x to the power 1 upon x, it is equal to 1. Okay, now using the rules of logarithm, we carry this 1 upon x here. So we get here limit as x tends to the 0, 1 upon x into log of 1 plus x, that is equal to 1. So it is equal to limit as x tends to the 0, limit x tends to the 0, log of 1 plus x divided by x. This 1 upon x, right? Below this log of 1 plus x, we write here 1 into log of 1 plus x, that is log of 1 plus x upon this x, and this is equal to 1. So the formula, third formula here, limit x tends to the 0, log of 1 plus x upon x, it is equal to 1. So these are very important formulas, three formulas. And on these three formulas, exercise 7.6 we solve. So again, see here, limit x tends to the 0, a to the power x minus 1 upon x, that is equal to log of a. Limit x tends to the 0, 1 plus x to the power 1 upon x, it is equal to e. And limit x tends to the 0, log of 1 plus x upon x, that is equal to 1. Now we see here exercise 7.6. Question first here, evaluate the following limits. Question first, evaluate the following limits. Evaluate the following limits. First example is limit x tends to the 0. Limit x tends to the 0. 9 to the power x minus 5 to the power x divided by 4 to the power x minus 1. Now see here, first formula we have seen just limit as x tends to the 0, a to the power x minus 1 upon x, a to the power x minus 1 upon x, x tends to the 0, it is equal to log of a. Now here a to the power x, here a to the power x. So we need here minus 1 for each a to the power x, because here a to the power x minus 1. So we adjust here 1. So it is equal to limit as x tends to the 0. Here 9 to the power x, we want minus 1, take minus 1. Now this minus 5 to the power x. Now cancel this minus 1 by taking here plus 1. And divided by here 4 to the power x minus 1. Means we have to use this standard formula 3 times. Here a to the power x minus 1, here a to the power x minus 1, here also a to the power x minus 1. But denominator should be x. Denominator should be x. So this is equal to limit as x tends to the 0. We take here 9 to the power x minus 1. Here take minus sign common. Minus in the bracket, this become plus 5 to the power x, and this plus 1 become minus 1. And divided by, suppose this 4 to the power x minus 1. Now to use this formula, a to the power x minus 1 divided by x. So we divide the numerator and denominator by x. Divide this numerator by x. Here also divide denominator by x. Get it? So this is equal to, we write here. So it is equal to limit as x tends to the 0. We separate the limit to numerator and denominator. Limit as x tends to the 0. Here also limit as x tends to the 0. In the numerator, we divide this x to this and this separately. 9 to the power x minus 1 divided by x and 5 to the power x minus 1 divided by x. Take the separate division. So 9 to the power x minus 1 upon x minus 5 to the power x minus 1 upon x. And in the denominator, 4 to the power x minus 1 upon x. And now use here standard formula, which is that since limit as x tends to the 0, a to the power x minus 1 upon x, that is equal to log of a. This is our standard formula. So it is equal to, in the numerator here log of, here x tends to the 0, here x, here also take limit as x tends to the 0. Okay, here we write minus and limit as x tends to the 0. We separate limit to every term. So it is log of 9. Log of 9 minus here log of, here a is 5 and divided by log of, here a is 4. And so it is equal to, now take here log common. When there is a addition or subtraction, we take log common. So it is log of 9 upon 5. When minus, take log of 9 upon 5 divided by log of 4. This is the final solution. Don't cancel this log and log. Okay, this is log of 9 by 5 upon log of 4. This is the solution of first problem. Now we see here second problem. Limit x tends to the 0. Second, limit x tends to the 0. 5 to the power x plus 3 to the power x minus 2 to the power x minus 1 upon x. Now in the denominator, a to the power x appear thrice. Here a to the power x, here a to the power x, here a to the power x. So every a to the power x must have minus 1 and divided by x and limit as x tends to the 0. And then the value is log of a. Get it? So we adjust here minus 1 plus 1 etc. So it is equal to limit as x tends to the 0. Here 5 to the power x, we have to adjust here -1, so take -1. Okay, plus here 3 to the power x, here we have to adjust -1, so we take this -1 here. Okay, so minus here 2 to the power x, we take -1 here, this -1 here, and we adjust only this -1, but take here +1. -1 plus 1 get cancelled, then this a to the power x, a to the power x, a to the power x, and this -1, and whole divided by x. So it is equal to limit as x tends to the 0. Now this 5 to the power x -1, here plus 3 to the power x -1, here take minus sign common, so it is 2 to the power x -1, minus sign common, here 2 to the power x, this plus become minus, and whole divided by x. So divide by x separately to every term, divide to this by x, this by x, and this also by x. And now here we take separate limit, take limit to this term also and this term also. So we get limit as x tends to the 0, 5 to the power x -1 upon x, plus limit as x tends to the 0, 3 to the power x -1 upon x, minus limit as x tends to the 0, 2 to the power x -1 upon x. And now use the standard formula I have written here. Write this formula here. Okay, since write this formula here. And so it is power is x divided by x, x tends to the 0, here power x divided by x, x tends to the 0, here also power x divided by x, x tends to the 0, then formula is log of a. So it is equal to log of, here a is 5, log of 5, plus here log of a is here 3, minus log of 2. Now here plus minus, so we take here logarithm common. So we get log of 5 into 3, 5 into 3, and minus log of 2, we write it as divided by 2, 5 into 3 divided by 2. When there is minus, we divide, and here plus, so take multiplication. So it is equal to log of 5 into 3, that is 15. So 15 divided by 2, log of 15 divided by 2. This is the answer for the second problem. Now see here, third problem. Third problem here, limit x tends to the 0. A to the power x plus b to the power x plus c to the power x minus 3 divided by sin x. So it is equal to limit as x tends to the 0. Here a to the power x we have given 3 times, and also here minus 3. So we write this minus 3 as -1, -1, -1. Okay, and adjust -1 to every a to the power x. So we get here a to the power x -1 plus b to the power x -1 plus c to the power x -1. We split this 3 as 1, 1 and 1. Minus 3 as -1, -1, -1, and divided by here sin x. Okay, to use standard formula, a to the power x -1 upon x divided by x. So we divide a numerator by x and also denominator by x. Okay, so divide numerator and denominator by x, and so we get limit as x tends to the 0. Here numerator a to the power x -1, this, plus b to the power x -1 plus c to the power x -1, and here denominator sin x. We divide numerator by x, so divide this by x, and denominator by x, so sin x by x. And now separate limit. So it is equal to limit as x tends to the 0. We separate limit to numerator and denominator, that is limit as x tends to the 0, and write here numerator, and in the denominator limit as x tends to the 0. Now in the numerator we divide by x separately to every term, that is a to the power x minus 1 upon x, a to the power x minus 1 upon x, plus b to the power x minus 1 upon x, plus c to the power x minus 1 upon x, and divided by limit x tends to the 0 sin x upon x. In the denominator it is standard formula we have seen in the previous exercise. So it is equal to, we take limit separately to every term, and so we get here limit as x tends to the 0 a to the power x minus 1 upon x, plus limit as x tends to the 0 b to the power x minus 1 upon x, plus limit as x tends to the 0 c to the power x minus 1 upon x, and divided by this is 1. Now this is the standard formula, power x divided by x tends to the 0, here also power x divided by x, x tends to the 0, here power x divided by x, x tends to the 0. So the formula is log a. So we write formula here, suppose limit as x tends to the 0 a to the power x minus 1 upon x, that is equal to log of a. Okay, so it is equal to, this is log of a, plus here it is log of b, plus log of c, and divided by 1. There is no need to write this one. So it is equal to, now take here log common, so log of, when there is addition we take multiplication, a b c, log of a b c, this is the final solution. Now fourth problem here, limit x tends to the 0 6 to the power x plus 5 to the power x plus 4 to the power x minus 3 to the power x plus 1 divided by sin x, divided by sin x. So solution of this problem, it is equal to limit x tends to the 0. Now to use standard formula, a to the power x, here minus 1 we want, and divided by x, limit as x tends to the 0, value is log of a. So firstly a to the power x, then minus 1 we must here. So 6 to the power x, take minus 1, plus 5 to the power x, take minus 1, plus 4 to the power x, take minus 1. So this minus 1, minus 1, minus 1, it is minus 3. So minus 3 to the power x plus 1, and this minus 3, and whole divided by sin x. Now here denominator should be x. So we divide this by x, numerator, and also denominator. So divide numerator and denominator. Divide numerator and denominator by x. So it is equal to limit as x tends to the 0. Now see here numerator is 6 to the power x minus 1, plus here 5 to the power x minus 1, plus here 4 to the power x minus 1. Now here we take minus 3 common. We write here suppose minus, and in the bracket here 3 to the power x plus 1, we write 3 to the power x into 3 to the power 1, and this plus 3. Okay, here minus 1, minus 1, minus 1, these are minus 3, and we have to take here plus 3, so that they will cancel. Now if we take here minus sign, this become minus, and then take 3 common. So here take 3 common, minus 3, and here in the bracket 3 to the power 1 minus 3, it is equal to minus 1. So minus 3 into 3 to the power x, that is 3 to the power x into 3 means 3 to the power x plus 1, minus 3 into minus 1, that is minus minus plus 3, and denominator here sin x. Now we divide numerator and denominator by x, means divide whole by x and denominator by x. Now in the numerator, divide every term separately by x. So we get limit as x tends to the 0. Now we separate limit to numerator and denominator also. That is limit x tends to the 0 in numerator, limit x tends to the 0 in denominator. Now here 6 to the power x minus 1 upon this x plus 5 to the power x minus 1 upon this x plus 4 to the power x minus 1 upon this x minus 3 into 3 to the power x minus 1 upon x, and here sin x upon x. Now in the denominator it is standard formula, limit x tends to the 0 sin x upon x, that is 1. Now in the numerator we separate the limit to every term, so we get it is equal to limit as, in the numerator we take limit as x tends to the 0 6 to the power x minus 1 upon x plus limit as x tends to the 0 5 to the power x minus 1 upon x plus limit as x tends to the 0 4 to the power x minus 1 upon x and minus 3, and then limit as x tends to the 0 3 to the power x minus 1 upon x and divided by limit x tends to the 0 sin x upon x, that is 1. So here divided by 1. Now in the numerator we use standard formula. Here power x tends to the 0. In every case here power x tends to the 0, and last one power x upon x tends to the 0. So here it is log of 6 plus this log of 5 plus log of 4 minus 3 into log of 3 upon 1, here upon 1. Which formula we use here? Limit x tends to the 0 a to the power x minus 1 upon x, that is equal to log of a. Get it? Now here we take log common, so it is equal to log of 6 into 5 into 4, here log of 6 into 5 into 4 minus log of, here take 3 power, so log of 3 cube, and divided by 1, here there is no need to write divided by 1. So it is equal to, again take log common, so we get here log of 6 into 5 into 4 divided by 3 cube. 3 cube means 3 into 3 into 3. 3 cube divided by 3 cube, and that 3 cube we write 3 into 3 into 3. Okay, 3 1s are 3, 3 2s are 6. So we get here log of 2 5s are 10, 10 4s are 40, 40 upon 3 3s are 9. So log of 40 upon 9. This is the solution for the fourth problem. Now we see here fifth problem. Limit x tends to the 0, limit x tends to the 0 a to the power sin x minus 2 to the power tan x, 2 to the power tan x divided by e to the power 2x minus 1. Okay, so it is equal to limit as x tends to the 0. Now here our standard formula is a to the power x minus 1 divided by x, power x divided by x. If there is a power x, then divide by x. Here power is sin x, and also here we want to adjust here minus 1 to every a to the power x. So firstly we adjust minus 1. So a to the power sin x minus 1 minus 2 to the power tan x. This minus 1 we cancel by plus 1 and divided by e to the power 2x minus 1. So it is equal to limit as x tends to the 0. Now this 8 to the power sin x minus 1, here minus sign take common, So it is 2 to the power tan x minus 1 and divided by here e to the power 2x minus 1 divided by e to the power 2x minus 1. We write this like this. Now we get here a to the power x minus 1. Here a to the power x minus 1. Here a to the power x minus 1. In the denominator a to the power x minus 1. In the formula, if power x divided by x. Here power is sin x, so we want to divide this by sin x. Here power is tan x, divide by tan x. Here power is 2 to the power x, divide by 2 to the power x. So we adjust this like this, limit x tends to the 0. Now 8 to the power sin x minus 1 divided by sin x. Okay, we divide by sin x. We have to cancel this sin x. So into sin x, okay, minus here 2 to the power tan x, 2 to the power tan x minus 1 and divided by here tan x. We divide by tan x. Okay, into tan x, we cancel this tan x. Now here in the denominator e to the power 2x minus 1. Now here in the denominator, here we want divided by x. So divide this denominator by x. Also divide numerator by x. We divide this denominator by x. So divide a numerator by x. So we divide this whole numerator by x and then divide separately to this term and this term. Means here we divide sin x by x and here we divide tan x by x. Get it? Commonly we divide numerator and denominator by x. Here we divide denominator by x, then numerator by x. Assume that we divide a numerator by x, then divide every term by x, means this term and this term. Here we want below sin x, write this x, sin x upon x, because we use the standard formula. And here x, write in here tan x upon x, so that we can use standard formula. Okay. Now here 8 to the power sin x minus 1 upon sin x, here sin x upon x, here also standard formula we adjust. But here e to the power 2x minus 1, we want here 2x. So take here 2 and multiply by 2. Multiply by 2. Now separate limit to every term, we get. So it is equal to, in the numerator, limit as x tends to the 0. Limit as x tends to the 0, 8 to the power sin x minus 1 upon sin x into limit as x tends to the 0 sin x upon x minus limit as x tends to the 0 2 to the power tan x minus 1 upon tan x into limit as x tends to the 0 tan x upon x, and divided by here limit as x tends to the 0 e to the power 2x minus 1 upon 2x and into 2, write that 2 here outside the limit. Now here every formula we adjust here. Only here power is sin x upon sin x should tends to 0. Here also power tan x upon tan x and tan x should tends to 0. Then we use standard formula. Now as here, since x tends to the 0, when x is 0, then what about sin x? Sin of x, that is sin 0. X is 0, sin of 0 is 0. So sin x tends to the 0. Also tan x, put x at 0, tan of 0, 0. So tan x tends to 0. Means here sin x, power sin x divided by sin x, and since x tends to the 0, there is obviously here sin x tends to 0. We have written here reason. And use the standard formula, limit as x tends to the 0, a to the power x minus 1 upon x, that is equal to log of a, and limit as x tends to the 0 sin x upon x, that is equal to 1, and limit as x tends to the 0 tan x upon x, that is also 1. And therefore we get here this is equal to log of 8. Here it is log of 8, log of a is here 8, so log of 8. Here it is 1, so 1 minus here log of 2, log of 2 into here 1, and divided by this 2 into here this as log of a to the power x minus 1 upon x, so log of e, it is log of e. So it is equal to log of 8 into 1, that is log of 8, minus log of 2 into 1, it is log of 2, and divided by 2 into log of e. Log of e is 1. We know log of e is 1. So it is equal to, we write this 2 into 1, 2, and it is 1/2. 1/2. Now log of 8 divided by 2. We take log common, so log of 8 divided by 2. So it is equal to 1/2 into log of 8 divided by 2, it is 4. Now carry this 1/2 here, power of this using the rules of logarithm. So it is equal to log of 4 to the power 1/2. We carry this 1/2 as a power. So 4 to the power 1/2. 4 to the power 1/2 means square root of 4, and square root of 4 is 2. So it is equal to log of 2. So this is the final solution for the fifth problem. So in this way we completed here question number 1st of exercise 7.6. Okay, we stop here.